Hello everyone! Here we have set of data. These three columns here represent a responses of teachers with their salary, current salary grade, and whether or not they are enrolled in postgraduate studies. Here we are going to test whether there is an association or relationship between the salary grade of teachers and whether or not they are enrolled in postgraduate studies. So we have here the first column would be for the teacher just identification, 1 until we have here 210. Okay, assuming we have 210 responses, so we have 210 teachers who were interviewed, and these are their salary grades. So we have 12, 11, and 13 just for this data, and these are the responses as to whether they're enrolled in postgraduate studies such as master's degrees and doctorate degrees. Now, this data here are both, with exception for the first one. Of course, the first one, the identification of which teacher responded. This one here, that's just nominal in nature. These two are also categorical in nature. More specifically, we can assign them as ordinal set of data. Because if we have here 12, of course, 12 is greater than 11, 13 is greater than 12, so we can assume ranks on the teacher salary grade. And we can also, the second one, you can also assume ordinal level of measurement, such as being enrolled is more than not being enrolled. But of course, we could also have it as categorical nominal data. The point here is we are going to test whether there's a relationship between the teacher salary grade and then their enrollment. If we talk about association, we usually use correlation, statistical analysis to determine whether there's a relationship between two. But if we're going to look into these two set of data, these are both non-numerical in nature. Now, even if salary grade are represented by 12, 11, and 13, they're actually just categorical in nature as well. So if we're going to test whether there's an association or relationship between two categorical variables, we are going to use here the chi-square test for independence. Okay, so we are going to use this type of test for test of association for two different categorical variables. Now here, take note that we are testing whether there's a significant relationship or association between the two. We are not testing here, or we're not going to claim causality. Like, we are not going to assume that one is being affected by the decision of the other. So we're just going to see if there's significant relationship between the two set of data. Now, before we start with the analysis, going here in our variable view, as I mentioned earlier, teacher is nominal in nature, okay? Because that's just the representation 1 till 210. Now, for salary, you can have your salary grade. We just simply labeled it with these values: 1 for 11, 2 for 12, and 3 for 13. You can even assign it like this, 1 and 11 here, and add if you would like to, but since it's already there, so we don't need to do that. We are assigning values that we could use the values 1, 2, and 3 in the analysis for SPSS, not the 11, 12, and 13. This is also true for enrollment here. We assigned 1 for enrolled or being enrolled in postgraduate studies and 2 for not enrolled. So we could do it like this here. But let me go here. Of course, we can assign ordinal for our salary grade. And let's just stick with nominal for our enrollment. Okay, it's just being enrolled or not being enrolled. It depends on you which is better than the other. But let's just have nominal for these two. So going back here, okay, before we start, let us have assumptions. Okay, of course, I'm already mentioned that we are going to use here the chi-square test for independence because these two are both categorical in nature, or one is ordinal and one is nominal. But before we could use this chi-square test of independence, the first thing that we need to do is assumption number 1. We must have two categorical variables. As mentioned earlier, this first variable is categorical because we have three categories: salary grade 11, 12, and 13. And the second is also a categorical variable. You could have here being enrolled or not enrolled. So these two already fits assumption number 1. Now, assumption number 2 is that there would be independence of categorical variables. That would mean that the responses of, let's say, 12 and 11 when one teacher is only going to answer 1, so only 12 and 11, he or she can answer 12 and what they call this one, 12 and 11 at the same time. And of course, we have here disenrolled and not enrolled as well. Only one response. So these are the two assumptions, because before we can use the chi-square test for independence, test for association between two categorical variables, and both have already been met. Now, before we go to analysis, let's also establish some hypotheses so that we could be guided in what to do in our interpretation later. Let's have our null hypothesis with the hypothesis of no difference. But specifically for association, let us have HO, teacher's teaching salary grade, is not associated with their status of postgraduate enrollment. Okay, so if this will be, if we fail to reject this, based on our data later in our analysis, that would mean there's no association or relationship between the salary grade and the status of postgraduate enrollment. And of course, our H sub A, our alternative hypothesis, teachers' teaching salary grade is associated with their status of postgraduate enrollment. Okay? Now, we can only reject our null hypothesis and of course claim probably the alternative based on this region of rejection. We reject our H sub O, or our null hypothesis, if we will get a p-value later on of less than 0.05, okay, with the default confidence interval of 95%. This would mean that if we reject that, we could say that teacher's salary grade is associated or has a relationship, significant relationship, with whether a teacher is enrolled in postgraduate studies. Okay, so these are now the basis of our interpretation later on, and we're going to do our analysis now. Now, for our analysis for chi-square test of independence, this is different with the pattern of chi-square goodness of fit test. Because in the chi-square goodness of fit test, we did this. We click analyze, we go to non-parametric tests, legacy dialogues, and chi-square. This is for the goodness of fit test. But there is a different pattern if we are going to test for independence or association for two categorical variables using chi-square. What we're going to do is this. Click Analyze, go to our descriptive statistics, and you go to crosstabs. Okay, again, Analyze, descriptive statistics, and then we go to crosstabs. Once you click this, you will have this dialog here. Okay. So this is a dialog for our chi-square test of independence. And what we need to do here is simply placing both of our variables in either rows or columns. Now, it doesn't matter which you will be placing in the rows and columns, or you just simply interchange them. It will have the same result, p-value result later. So if you have here teacher salary grade, place it in rows, and you have postgraduate enrollment, place it in your columns. That's already okay. You can click OK here. But of course, let's proceed to our statistics for some additional checks. We'll have here statistics, and let's check here chi-square. Okay, so that we would know that this is really a chi-square test for independence. This is also checked. This is the phi or the Kramer's V. This is for the effect size. Most of the references will say that this is actually a better way for interpreting the result, but more or less similar in most of the tests that I did. We will have closely similar values for P. But this is for effect size. Okay? So we'll have those two and click continue. You could also click cells here. Okay, because you would like to see as well the expected. Now, the expected, same, because this is chi-square. Chi-square in general talks about the differences between observed and expected values. We might check this one here for more interpretation and discussion if you would like to. Once you check that, of course, you click continue here. Now, all of these are now set. You can now click OK. Once you click OK, you will have this result. Okay, you will have 1, 2, 3, 4 tables here, and let's talk about them one by one. The first one is a case processing summary, just a summary of all the cases that you've placed there. We have 210. Now, you might notice here 40. Sorry for this. Going back to our data earlier, we already have 210, right? But I was not able to remove or cancel this here 250. These are the missing cases, but you don't need to worry about this because there are no values here in the first place. I was not able to remove this. So probably like that, you will just see some missing cases. But don't worry, this 210 will still be the 210 that will appear here on our second table. So this is just a summary of all the cases that you had. Now, the second table, as mentioned, this will tell us about the cross-tabulation of expected and our observed results. So our observed, this will be our 27. 27 means here, 27 teachers responded with a salary grade of 11 and they are enrolled in our what do you call this one, postgraduate studies. 49 responded salary grade 11 but not yet enrolled. So these are the responses. The expected count, we have a manual computation for that. That's total row times total columns divided by this one here. You will get that. I'm not going to talk about that manually. So these are all the indications. Now, we are going to proceed here to the chi-square tests. Okay, this test here, let's focus on our person chi-square. Right? This value here is our chi-square value. This is what we are going to check with our chi-square distribution table if we're answering this manually. And of course, using the degrees of freedom here too. The degrees of freedom here is our, what do you call this one? This is computed by the n-1 times k-1. Okay, n-1 means we have here number of rows, 3 minus 1, that's 2. And k columns, 2 minus 1 is 1, so 2 times 1, 2. Again, you don't need to worry about that because that's on manual calculation. This is being referred to our chi-square distribution table, but here in SPSS already given automatically with our p-value. This is our p-value here, 0.30. This is the significance value on whether there is an association between teachers' teaching salary grade and whether or not they are enrolled in postgraduate studies. As you can see, this is 0.30. This is less than 0.05. What does this mean? We are now to reject our null hypothesis, the hypothesis of no difference, and say that teacher's salary grade is associated with whether or not a teacher is enrolled in postgraduate studies, that's such as MS and PhD studies. So this is now the indication. Looking back here, this is our Phi and Kramer's as well. Now, Phi is good for 2x2 cross-tabulation, but this is a 3x2, so we'll have Kramer's V for that because Kramer's V can be used for tables which are more than 2x2. Nevertheless, we have the same values for significant value or p-value, 0.30, which again less than 0.05. Hence, we reject our null hypothesis. Now, nowhere here mentions a certain strength of association. That is one thing we need to be reminded of. We're using chi-square test for independence. We don't have the strength or the magnitude, the direction of the association or relationship, unlike the correlations that we are using for our what do you call this one, parametric test. We will be given with R value. Here we don't have the exact value for association. For chi-square test of independence, we are just given with the significance value and whether or not there is an association or not. No strength, no magnitude. At the same time, of course, this doesn't tell us any causality. So going back to our data here, based on this data with their salary grades of teachers, 11 I believe for teacher 1, 12 for teacher 2, 13 for teacher 3, and whether or not they are enrolled or not enrolled in postgraduate studies such as MS and PhD, just for this data alone, we can say that there is an association, significant association between the two categorical variables. And this is how we use the chi-square test for independence for two categorical variables, just looking for the possibility of association. See you in the next video.